right, guys. So today we're going to be integrating with respect to y. Now, technically, that doesn't really matter. So procedurally, it doesn't make any difference. This and this don't make any difference procedurally. The way you would calculate the answer is exactly the same. It's just the idea, the concept when you're thinking of graphs is different. The concept is different. So you guys I want you to know how to think about this a little bit as we're doing these problems. So let's go ahead and begin here. Let's talk about what a function of x and y even is really quick. So let's say I have this function here, y equals x plus 2, right? And I wanted to graph this. So let's pick a few points here. I'm going to plug in 0, 1, and 2. If I plug in 0, I get 2. If I plug in 1, I get 3. 2, I get 4, right? This, though, this is a function of x. And what I mean by that is x is the input, y is the output. And so when you have something written as a function of x, your equation has an x in it. Now, let's take this same equation, though, y equals x plus 2. And let's get the x by itself instead. What would it be if I got x by itself? It would be y minus 2. Now, in that case, this is now what we would call a function of y. Oops, wrote it wrong. That's a function of y. It's literally the same equation, though, isn't it? I just got a different variable by itself. But it's still true. Like, if you were to plug in 2 over there, what would you get?
0.
If you plug in 3, what do you get? So you get all the same points. It's just that it's a function that's being integrated with, or not integrated. It's a function that is in terms of y instead of x. Well, today we're going to be doing some integrals, but we're going to be doing them with respect to y. So first of all, let's compare and contrast these a little bit. When you're integrating with respect to x, let's say I have a curve that looks like this, right? We're finding the area that goes from the curve to the x-axis, aren't we? And that's a positive area in this case, isn't it? Let's go ahead and stretch it out a little bit, though. And then we're finding that area, too. That area would be what, though? Negative. Okay. What if I wanted to find the area under this curve? What would I do? I would have to integrate it, right? From what to what?
From A to C.
You can go from A to C, sure, and that would give you the total answer, right? Now, what if the person asking you the question said, well, yeah, I understand that this is negative, I understand that this is positive, so they're going to cancel a little bit, right? But what if I don't want you to have them cancel out? What if I just want to know what's this area plus this area, thinking of it just as positive? If you just make it an absolute value, then you're finding the total area. Does that make sense? So you're not paying attention to negatives and having things cancel each other out. If you just do absolute value, you get the whole thing, right? But what are these here? The A's and the C's. Those are all x values, right? Let me rewrite those actually, now that I've thought of that. So this is x1, x2, x3. Those are x values. All right. Well, when you're talking about a function of y, okay, well, it could take on a few different forms, but I'm just going to make it kind of look like what we have here. They're sideways functions, okay? So in this case, instead of finding the area from your curve to the x-axis, we're finding the area from our curve to the y-axis. Now let me ask you guys this. Do you think this area would be a positive area or a negative area, and why do you think that?
Positive.
Why would it be positive? So, yeah, so the key answer is because it's to the right. It doesn't matter if it's above the x-axis, because what matters is that when you have a function of y, like this, for instance, like the one we had in the last page, let's say it was that. This represents the x value, right? Now, what kind of a number? This, you got to remember, this picture is not for this equation, but what kind of a number could we plug in here so we get a positive x value? Like 4, right? So, in other words, you have to plug in positive x values, bigger x values, and those are located where? To the right, okay? So that's what's going to give you that positive x value outcome there. So if you want to get positive x values, you're going to have to plug in y values that will give you that. And so we're looking at stuff that's to the right. And so therefore, anything that's on this side over here would be a negative area, okay? So there's our that. And we're integrate. If we want to find the area, we would integrate it, right? What would my limits be though this time? Those are y values. So instead of integrating from left to right, we're integrating from bottom to top. Okay, so it's y1, y2, y3, and what you'd have to do is you'd have to go from y1 to y3. If you just want to find the integral, that's fine. But if you want to find the area and not have areas cancel out, absolute value once again. Yeah.
If the graph was below the x-axis, would it still apply if it were
To the right and left? Yep. So like for instance, if I had this, that would still be a positive area. Yep, because it doesn't matter whether it's above or below. Just like when you're doing this one, if we're back here, that's still a positive area, right? Even though it's behind the y-axis, it doesn't matter. It's because when you're doing things with respect to x, above the x-axis is positive, below is negative. When you're doing things with respect to y, to the right is positive, to the left is negative, regardless of how high up or down you are. So we're going to be integrating functions with respect to y today, and that's pretty much the concept behind it. Probably going to skip a few slides here because I wanted to come at it from a slightly different angle. All right, let's see. So
I was like trying to undo it.
I'm going to skip a couple things here. Now, you guys. Okay, guys, can I have your attention, please? We're going to resume. So why did we do this? Well, last night on your homework, I gave you guys a problem that was a little bit like this. Okay, and to find the area under the curve, you would have to split it up into two pieces. You would have to find this area first, so you'd have to do one integral for the area under the f function from 0 to a, and then you'd have to do another integral for this area under the g function from a to c to get the total area. But if we think of these as functions of y, functions of y instead of x, then what we could do instead is we could find the area that exists between this curve and this curve. How do you find the area between two curves again? You subtract them. Which one of these functions is bigger than the other one in terms of y?
f of y.
Somebody care to share an opinion why they think their answer is what it is? So I heard different answers. What do you think, Brandon?
It's curving over the y, the f function.
Okay, so you, like over here, you see the f function's above it. Is that what you're saying?
Yeah.
Okay. Any other thoughts? Yeah. G of y starts higher. Okay. Now again, different answers, different explanations. Let me give you guys some information. When we have a function that is with respect to y, Bigger means which direction? Left and right, right? So which one's right? So which one's bigger? G of y is bigger because it's further to the right. So what we would do here is we would say, if I want to find the area between these curves, I would take my g function and I would subtract from it my f function to find out how far apart they are. And then if we add up all the distances between them, we would get the area, right? So now, but question, if I'm integrating with respect to y, what are my limits going to be? Which are 0 to k. Okay, so now that would be less work and easier to type into a calculator than this one. Like on your homework last night, I think you had to find where they intersected too, didn't you?
Yeah.
I don't know, something like that. Yeah. So here, you just go from the bottom up to the top there, subtract your two functions, and you got it. So one reason why it might be beneficial to integrate with respect to y is because it might be theoretically simpler to do. All right. Here's another reason why, because of what I showed you earlier today. Sometimes they just want you to find the area from a curve to the y-axis. They don't want you to find the area from the curve to the x-axis. They want you to find the area to the y-axis, in which case you have to do things with respect to y instead of with respect to x. So that's why we want to do that, and that's where we'll start today. So there we go. Let's do example 1 real quick here. So for this problem, it's asked me to find the area between the curve and the y-axis. So I'm looking for this area right here. Okay? Now, I'm integrating from what to what? Because those are the y values that we're going from bottom to top, right? And that's f of y dy, right? But I mean, that's it. I mean, so I just want you guys to be aware of the fact that you use these limits. After that, our calculator work is literally all the same. It's just the thing is that when you're putting in your calculator, when you're typing in, what letter are we going to use? We're going to use x because our calculator doesn't have y's on it. Okay, but it doesn't matter. You're still going to get the same answer anyway. And here's why. Let me show you guys this. I don't want to freak you out too much, but if I just replace all those y's with x's like this, it is a different function than that one. If you graph it, you know what it would look like? It would look like that. It's the same shape, it's just in a different place. So it'll give you the same area. So it doesn't matter if you use x's or y's on your calculator, okay? So go ahead and let's type this into our calculator and see what we get. Tell me what you get when you get it. 10.6. 7? Okay. Okay, so go ahead and you guys try this one really quick. See what you get. So what are my limits here? Now you guys get 0. Now I'm going to do something that's probably a little bit frustrating to you, and I understand why it would be frustrating to you. I haven't been entirely clear about something, and I never am every year up until this point, so I'm going to try to be clear now. There's a difference between somebody asking you to find the area between a curve or whatever and saying find the value of the integral. Okay? This is the answer to what is the value of the integral. But if I want to find the area, what do you think I should do? Yeah. So this is you might want to write this down. This is the value of the integral. But if they ever ask you to find area, you guys, what they're telling you is they want to know how much space is taken up. And yes, I understand that this one's a negative, this one's a positive, but when they ask for area, they're asking about absolute value stuff. They don't care about which one's positive and negative. So the area under the curve is actually going to be this. Now you didn't know, so that's not your fault. I did that on purpose. I just because I wanted to have this moment to talk about that with you guys. But there is a difference between the value of the integral versus the area to the curve. So if they ask for area, absolute value, okay? And it's kind of, here's another thing that I do that I shouldn't, but I do it so things make sense. I say slope constantly. But should I say slope? I should say instantaneous rate of change, or I should say derivative, because those are different ideas, right? But I just do it so things make sense. So I've been calling this like an area, but technically that's really just the value of the integral. The area is the absolute value. So this is area. So now, did somebody get a chance to calculate it yet?
Yeah.
0.5. So there's our answer. Which means that what's this area probably? 0.25, and this is also 0.25, right? So, because it looks like they're exactly the same. Yeah.
Is like for some of them, like can't you just tell visually, like with this one you can tell that if you like really read it this slowly, since it's on 0, there is no like area between the axis. So what if it was like down 3, like you be able to just do it mentally by looking at it?
Are you talking about the fact that these look the same, but one's negative, one's positive? You just know they're going to cancel.
And then they're on the axis, so there is no like distance on the axis, right?
That part I'm not understanding.
So like, all right, so you know how the y's like on the axis and
So this is yesterday's lesson. You guys remember how it was top minus bottom to find area between two curves? Well, when you're doing functions with respect to y, it's not top minus bottom. What is it? Right minus left. So the function on the right minus the function on the left. Okay? All right. So let's do example 2 here. Did I print this for you guys?
Yes.
Okay. So we have two functions here. We have, I'll call this one x1. It's a cubic function. It looks like this. It's a sideways cubic function, right? And the other function up here is x2. Notice it's x's instead of y's because we're doing functions with respect to y rather than with respect to x. So my x2 function is a quadratic. It's this one. And there's two areas there. Now, let's go ahead and do this. So, how many area pieces do you guys see there? We see 2. So that means we're going to have 2 separate integrals here. All right? Now, my first area piece, what am I integrating to and from for that first integral piece? Well, the first one, we're going to start on the bottom. It's this one down here. I'm going to start here and end here. Remember, we're integrating not left to right anymore. We're integrating bottom to top. So I'm starting here to here. What are those y values? 0. Now for that particular region, right, which one comes first, x2 or x1? Why x2?
Further to the left.
You're right. Or further to the right. So the green function is farther to the right than the red one, right? You see that? You guys agree? Okay, so the green is to the right of the red in that area. We can ignore this. We don't care about this. We're just looking from -2 and up. So for that bottom piece, the green is to the right of the red. So we're going from -2 to 0. It's x2 minus, oh, I wrote that wrong, x1. Okay, now the next little area that we need to integrate is going from what to what? 0 to 3, right? From here to here. We're going from bottom to top. And for that region, which one comes first? x1, because in this case, the red line, the x1 function, is to the right of the green function. Now we talked about this yesterday, or last time we had a lesson anyway. By the way, you guys notice I'm putting dy here? Because we're doing functions with respect to y. Okay? And these are y values on the limits, right? And that would give you the total area. Now 2 days ago when we did this though, instead of doing it 2 different ways, we talked about how this expression and this expression, I did it again. There we go. All right. We talked about how this expression and this expression are the same if we what? If we take the absolute value of them. And if they're the same, since we start at -2 and go to 0 and pick up at 0 and go to 3, we can just put that together into one integral, right? So I can just do this and have the answer, right? Just like last time, it's just that our letters are switched around. So instead of just finding the area of this piece down here first and then this piece separately, by taking the absolute value, it doesn't matter which one comes first. It's just going to give you the total area anyway. Okay? So now we get to type this into our calculators and find the area. So let me bring one up here. Okay, so if you guys want to do this with me, you can, or if you just want to watch, that's fine. But I'm going to go into y equals, and I'm going to type these functions in up here. I called this one x, what did I call this one? That was x1. So I'm going to type that in the y1 spot then. And so instead of -y cubed, I'm going to put -x cubed plus 6x. And for the other one, I'm going to put -x squared. Then I'm going to go back to my home screen, and I'm going to do Math 9. And we're going to do the absolute value, right? Forgot about that. Math num. Y1 minus y2. And we're going from what to what? So how you guys get your answer doesn't really matter. It's the same thing that we've learned already. It's just you have to learn how to look at it a little bit differently. Okay? You're getting your limits of integration are y values, and your functions are sideways. So graphically, it kind of creates a problem for us, but algebraically, there's no difference in how you do it pretty much at all. So 21.083. So I'm going to let you guys try one real quick. All right, you guys try that one. By the way, when you guys do this, my encouragement to you would be anything that's a fraction, when you guys are typing this into your calculator, I would encourage you guys to put each of your fractions in parentheses. Calculators have a hard time if you don't put your fractions in parentheses. So put your fractions in parentheses. Guys go. All right, I had more, but we're low on time, so I think we'll stop there. And that really hurts. So guess we'll call it a day.